Yeah, good morning. So I think we all agree it's been a very, very good meeting so far. So my title is Immune Dysregulation and Autoimmunity in Long COVID. And I'll talk about those things to some extent. I won't show you a lot of sort of detailed immunological data, because what I wanted to try and use my talk to do was to kind of pull together some of the themes in this area from the meeting so far, and what I feel, from my point of view, we could or should be doing together better. So those are my conflicts. So, you know, we've all come a long way, haven't we? So if you search for long COVID or PASC on PubMed, you get close to 40,000 publications. That's an awful lot of publications, good, bad, and quite a lot of them indifferent. And I don't know about you, but when I meet up with sort of activist groups online, they sort of pummel me with sort of all this stuff that's out there, and, you know, why can't you all do better if you know what, if you publish these 40,000 papers, how many do you need, for heaven's sake? And, you know, I think the answer is we just need to do better and agree more and take the right steps. So this is a slide that's already been shown before. It's from Ziad's paper. So we did an analysis in Nature Reviews in 23, and then more analysis in this piece in Nature Medicine a few months ago, where the estimate, the calculation is 400 million people in the globe with long COVID, and, you know, truly mind-boggling figures for lost GDP and lost workforce and global economic impact. And I guess we all share frustration in this room that those figures really are horrendous. And yet, when we speak to our departments of health and our governments and our healthcare providers, it's very hard to get any comprehension and any engagement. And there's a kind of disconnect there. And I guess it's our job to try and close up that disconnect with any brain wattage we can amass to do so. There was some talk yesterday about lessons from previous post-viral sequelae and how long will it last. And for me, early on in this, I was interacting quite a lot with long COVID patient groups. And one of the most common questions to me was, you know, you must know about other similar viral infections. How long will this last? How long will I have this for? And I felt very ignorant. I didn't really have a remotely intelligent answer or a reference point to draw on. So I became very obsessed with trying to track down doctors who'd worked with the SARS-1 cohort in 2003, 2004, and find out what happened to their patients. And eventually, I managed to make friends with this chap, John Patkai, in the University of Toronto Healthcare, who looked after that cohort of Toronto healthcare workers. And I commissioned a review article from him about his experience with the long SARS patients. And he wrote this article for me, and have a look at it. It's in Oxford Open Immunology. That was so devastating, I hardly dared cite it, because he finished it with, you know, you didn't read it all, but with this thing that says, you know, in summary, none of our 50 patients ever got their old life back with time and treatment. Some were never able to return to work. Some had a trial return to work and failed. So that's 20 years later. So, you know, if we needed any greater incentive to actually try and do something, you know, that's it. You know, if we can't do anything, this probably isn't going away. And so in the meantime, in that process of getting together with long COVID patient groups and things, I got together with one patient activist called Jez Medinger, and we wrote a book together for Penguin called The Long COVID Handbook. And I promise I'm not showing this in a kind of sort of big head showing off way. In a sense, the opposite. If you have a look at the small print there, I proudly took this screen grab the first day it appeared on Amazon. And if you look at the screen grab, it says that on the first day, 2 people were selling used copies. So clearly there were some people where it didn't kind of go down that well. But it's kind of meaningful to this discussion in terms of, you know, how we bring together the different parts of the community. And, you know, in this meeting, we've got, you know, huge and appropriate representation and interface between the patient groups and the clinicians and the scientists. And we have a chapter that Jez and I wrote for this book, which I think it's chapter 8 or so on therapeutics. And we almost came to blows about this, and Penguin had to call in the divorce lawyers because he was writing very Very daring stuff about sort of n=1 experiments he was doing on himself with some very dangerous treatments. And I was playing the boring professor, kind of poo-pooing those treatments and saying, you just can't do that. And you can't even write that because, I'm a professor at Imperial College and they'll sack me if I'm on a book that has these kind of comments in it. So in the end, Penguin agreed that we would write it as a kind of sort of professor and patient debate about the different approaches to long COVID, but it does kind of exemplify the kind of really problematic space we're in. And a point I'll come back to about, the despair of some of those long COVID patients. And then we wrote a more academic version of where we thought in the lab immunology of long COVID was, and that's in Nature Reviews in Immunology, if you want to look at it. It was mentioned yesterday. So in that we talked about all the obvious mechanisms that are on the table. All of which have varying degrees of support, which I think shows just the complexity of the pathophysiology of trying to pull this together. And these are all the things that we've all talked about from the very beginning, aren't they? The idea that if you've got a cytotoxic virus that binds to cells in the body that have ACE2 receptor, you're going to be able to see organ damage in several different organs at the level of things like MRI and PET, and that one where perhaps we're accruing quite a really good body of evidence that I'll talk about a little bit, and we've heard a lot about at this meeting and will do, about the idea of some kind of persistent virus or antigen reservoir, the idea that herpes viruses, particularly EBV, get reactivated, just that whole body of work that occupies a very large space, quite rightly in long COVID, that downstream of acute SARS-CoV-2 infection, there are different forms of immune and inflammatory perturbation. The idea that it's a kind of endotheliitis with downstream effects on coagulation. The evidence out there on what one could call mast cell activation, or certainly some kind of altered allergic profile. I'll talk a little bit about de novo induction of autoimmunity as a consequence of SARS-CoV-2, and then not that much data yet, but some quite persuasive observations on dysbiosis. So all of those things are out there. They're not mutually exclusive, and they just show how complex it is to try and put together this pathophysiology. One of the big things I want to say, I know there are many biomarker studies and many biomarker experts in this room. Can I just make the comment, just as the person who likes to kind of state the obvious, that there are many biomarkers out there. I think the meta-analyses show whatever it is, 140, 150 different biomarkers that have been produced, and I think the fact that as a field we haven't managed to get our act together to agree biomarkers that we could use for diagnostics, for public health, for referral and care pathways, for study recruitment, for study endpoints, is such a bottleneck that we should have been able to do better. We should do better. In other fields, by this point, it's been possible to organise international workshops, to share reagents, to share sera, and I don't say this in a sort of condescending or patronising way, like you should have done better. We should have done better. Could we not try and agree that when we meet next year or whatever, we'll have tried to set something up and do some reagent sharing and do some standardising and do some validation, because people can't make sense of what we're doing. Every few weeks, every few days, there's a different paper with a different set of quite persuasive-looking biomarkers with some quite good p-values. And my general doctor doesn't have a clue what it's all about and doesn't have a clue which one they're meant to be using or how they could order the test. So there's so many reasons to state the obvious why we do want to be able to do better. So yeah, I know as an introduction. So one of the things that we did some years ago was to set up this study, which is called WILCO, which is called Working Out the Immunology of Long COVID. So in the kind of UK context, there's a hospital-based study called FOSP, which stands for post-hospitalization. So that's trying to scoop up as many cases as possible from the first year of COVID in the UK and track what became of them and what becomes of them. This is the kind of complementary study that essentially looks at those people who weren't unwell enough to be hospitalized, but nevertheless have full-blown bona fide long COVID. And we track them with time in terms of their symptomology and symptom clusters, and the kind of full array of immunology tests that immunology labs do. And a few comments from that cohort, which are similar, I think, to all the cohorts that you're all looking at, which is that we've now called them back for their longitudinal studies, and many of our cohort are now 3 or 4 years plus out. And when we call them back at 2-year intervals, the majority of them are not better. Some of them are a little bit better. Some of them have stayed the same, and some of them have got worse. So, without catastrophizing, I'm not saying it's necessarily, hopefully not the same as that SARS-1 cohort, who were, after all, quite serious, hospitalized, largely ITU patients who literally haven't got their lives back at all 20 years later. I'm absolutely not trying to catastrophize and say it's going to be like that. But these people aren't getting better anytime fast. That's certainly true. And when we, sorry, the detail on that is hard to see, but you'll get the gist of it, that if you look at them sort of symptom by symptom over that 2-year span, as they went typically from 18 months into their long COVID journey to 3.5 years into their long COVID journey, yes, there are some of the symptoms on that 84 questionnaire that have got somewhat better, like their, for example, their memory problems, things like that. But many that are just stuck and have stayed the same. Yeah. So to mention some of the themes I guess we'll be talking about in this session, the idea of a persistent virus reservoir. So again, this is one of the areas where there's been super data, not least from some of the people I can see in this room. My interest and excitement about it came, I think, largely from this paper that people may know, which was the first one that kind of tied up different observations and different hunches. The idea that if you almost kind of opportunistically take people who are being referred into a gastro clinic because of their inflammatory bowel disease and therefore getting endoscoped, and tissue samples are being kind of thrown in the bin, and you rescue those tissue samples and you try and tie up whether you can get any immunohistochemistry evidence for SARS-CoV-2 with whether those people answer questions in the questionnaire that make it sound like they have long COVID, you get a very good tie-up. Okay, so it sounds like a kind of small paper, but so many kind of quite profound points out of that. I think one, here was yet another thing that a coronavirus could do that we all swore they couldn't do. I mean, unless you were, an aficionado of feline coronavirus, who knew of examples where a coronavirus could set up a really long-term persistent infection in the gut? I certainly didn't. So that, and that kind of sort of heuristic that immunologists fall into, where they say, oh yes, it's obviously persistent antigen in the gut. But what even does that mean? What is the persistent antigen, and where's the live virus, and why is it sitting there, and how is it sitting there? So I think we've got to be careful not to be intellectually lazy and just say, oh yeah, we've solved it. It's antigen in the gut. What does that mean? And if it's in the gut, where else is it, and what other tissues should we be looking at? So all of the above. We do a ton of immunology to try and tie in with that and try and spot the people in our cohort who really do have biomarkers of possible persistent infection through many different parameters and might benefit from whatever trials, antivirals, monoclonal antibodies, so things like this. So in our cohort, if we, it's not black and white like all immunology, but if you look at our Wilco cohort, and do T-cell assays, cellular immunology assays, to look at responses to the immunodominant epitopes in spike, you see that they've actually got quite substantially enhanced ongoing responses to spike. And again, I think it's noteworthy because when we speak to patients in our cohort, and they've all done a lot of reading and they're all informed, but there are many different sort of feelings out there from people who feel they have long COVID because their adaptive immune response to the virus was inadequate, to the people who feel they've got long COVID because their adaptive immune response to it was excessive. They might both be right, but we kind of need the assays. I don't know, but there are many hunches and suppositions out there, and we just need we need the biomarkers, and we need the answers. And this you've seen once already. The senior author is sitting over there. It's one of my favourite pieces of long COVID evidence, and one of my favourite publications among many that I always show, that I think moved us onto a whole new level in terms of trying to look at this, not least because of the advances to PET methodology in terms of being able to track CD8 T cells to sites of the action and show that they were different and had different and unexpected tissue localization corresponding to places where one could find virus in gut biopsies in long COVID patients. And I think that was a huge step forward. So I really do admire and respect that paper as a really kind of quantum leap for all of us. And we're all off now trying to identify kind of clever PET collaborators who've got clever PET tracers who can do things like that with us, because I think it's a big part of the story. We've got another important author in the audience in terms of transcriptomic biomarkers, which again could and should form part of the array we have for analysing this stuff, and then many aficionados of altered coagulation and clotting. So I think the challenge for us is to put all these things together into some kind of coherent pathophysiology, because my fear is that, having shared this kind of wartime spirit during 2020 to 2022, we're now going off into our CV, building silos and becoming coagulation people or complement people or autoimmunity people, and we actually need to kind of stick together, because it's just one disease process we're trying to resolve here. Lots of quite interesting evidence I just wanted to mention about induction of de novo autoimmunity. And again, I think it's another thing where we shouldn't be guilty of any kind of lazy thinking, like, oh yes, viruses lead to autoimmunity. We've got lots of examples like that. Do we? And how well proved are they? And what's the mechanism? And what are we saying? That viruses can turn on autoimmune B-cell plasmablasts without T-cell help, or that they disinhibit Tregs? What do they do? And who's showing? Show me the good papers where we've actually done the homework to prove it. We've certainly done an enormous amount of work on whole human proteome autoantigen arrays in several cohorts, and we find many new autoantibody specificities, and many of our long COVID patients really light up those fluorescent arrays like Christmas trees. And they're not specificities that we've seen before, and some of them are so-called pathogenic, and some of them are missing in the long COVID cohort, as if they've lost some protective autoantibodies. So, there's a whole science of autoimmunity to be decoded there. And that's too small to see, but it comes out of the Nature Reviews paper that we published, and it's our listing at the time we wrote it, summer before last, of all of the autoantibody panels that have been looked at. And I guess it tells a story that whether you pick proteome arrays, or whether you pick your favorite lupus panel or POTS panel or GPCR autoantibody panels, you find differential responses in long COVID patients. But how do we, climb above that, to get the answer and get the tests we want? And a very nice one, I don't know if any of that group are here, from Milan, again showing this kind of concept of present pathogenic antibodies, but also absent protective autoantibodies, here in the case of chemokine receptors, mapping to long COVID. And as if that wasn't complicated enough to get your head around and for us to explain to people, all of that presumably tracks into this thing that we see in electronic healthcare records across publications in several different countries now, showing that aside from any autoantibody analysis or fancy immunology and things, if you look at a population level and compare first waivers who had COVID-19 compared to people who definitely didn't, your risk of many classical autoimmune diseases has gone up 2 to 3-fold. So, the last few slides are presumably mechanistically related to each other, but how, and how do we tell that story? So, moving to finish up, all of those hypotheses lead into potential therapeutics if we could get our act together and pull together those randomized controlled trials. And again, the other plea, I've already said, I think we need to work harder together to agree on our biomarkers. I also think that in randomized controlled trials, there's some thinking to be done together, because I think there are too many trials out there where we haven't thought through and agreed hard endpoints that regulators can buy into and sort of government service providers can go into, where they can believe us and where we can show clear-cut, hard-nosed difference from placebo in our control groups. So, it's an area where it's not obvious. If we haven't agreed to pathophysiology, what are our endpoints? So let's please try and do that. And, because the patients, many of them, here or online are desperate. This is a survey from one very well-known patient activist who's offering up any of his tissues for biopsies because they're desperate. And in his online survey, 74% of his followers said they'd give bits of their body for research. So we don't want to ask that, and we haven't got the ethics to ask that, but it does show how irritated they are with us and how desperate. So to finish up, we've learned so much, but we need to kind of, I think, meet again next year and do better and talk to each other, nationally and internationally, across our silos. And, there are implications not just for long COVID, but for other post-viral sequelae, chikungunya, Ebola, you name it. We so urgently need to get our heads together and agree internationally our biomarkers, our symptom clusters, and try and illuminate this area. Because it's really holding us back, and we need really scaled up randomized controlled trials with some momentum, including agreed endpoints. And the other whole discussion that we had in the session yesterday, we do need to get our heads together to work out what the cases that we're trying to make to our departments of health and our healthcare providers about what long COVID clinics should look like in the future, because they are unfortunately going to have a long future. And we need to work out, what are they meant to look like and who's meant to be in them and what are they meant to be doing. Thank you.